we have powerful smartphones and applications that can be used for various physics experiments. And so for our first activity, that will be the pendulum experiment with the objective of calculating the acceleration due to gravity. And as Dr. Mero has mentioned in the video, this activity can be done in classes discussing topics in mechanics. I would like to encourage everyone to follow the procedure on the worksheet sent to you while watching the video prepared by Dr. Francesca de Vera and Sir Nelio Altoveros on the pendulum experiment. So later on, they will be here with us to entertain questions. So can we now flash the video on the first experiment?
Hello everyone. This DIY experiment is about simple pendulum and measuring Earth's gravitational acceleration. Possible learning objectives are: set up a simple pendulum experiment using a smartphone and FilSciHub application. Measure the period of a simple pendulum of various lengths and mass. Determine the acceleration due to gravity using a simple pendulum. Materials for this activity are smartphone with FilSciHub application, ruler, tape, string or cord, cardboard or thick plastic, coins, and weighing scale. In this activity, we will use an application called FilSciHub. FilSciHub is a free access software that allows you to use the mobile sensors in your experiment that supports the following inputs. For the pendulum, gyroscope sensor will provide period and frequency oscillation of the pendulum. Setting up the pendulum. Setting up the mobile phone as the pendulum bob may be a little tricky. Here, using mobile phone alone as a bob results to spinning or additional rotation of the pendulum. To eliminate this, we will use a slightly modified version of a simple pendulum as shown. First, make a pouch that can hold mobile phone and coins using a thick plastic container or cardboard. Step-by-step procedure on making a pouch from cardboard is provided from the teacher's guide manual. You may also let your students design their own pouch to develop resourcefulness and creativity. Tell your students that the pouch should be strong enough to hold the phone and coins, and it should be act to minimize the spinning motion of the pouch bob as it oscillates. Data measurement using FilSciHub. Start the FilSciHub application. You can see different types of sensors and tools you can use. For this activity, select the pendulum experiment in the mechanics category. Results give the average period and frequency of oscillation. G gives acceleration with the given pendulum length. Length gives the pendulum length assuming the theoretical value of G. Here is resonance, autocorrelation, and gyroscope data in X, Y, and Z axis. To gather data, click on the three dots on the top right of the application. Click on Do a Time Graph. Set the start delay to 3 seconds and the experiment duration to 10 seconds. Activate the acoustic signals. We can also access the gyroscope data as shown. To save, click the three dots on the top left and select Export Data, then press OK. The first part of the activity is measuring the period of the pendulum with varying mass. The students may do this by attaching different number of points in the pendulum's bob. The students may analyze their results by plotting the period versus the pendulum's mass. The second part of the activity is measuring the period of the pendulum with varying lengths. The students may analyze the results by plotting the period versus the length of the pendulum. Finally, by plotting the period versus the square root of length, the students may obtain an experimental value of g. Encourage the students to take a picture and video of their setup. You may be surprised by their ingenuity. Thank you for listening.
Alright, so that's it for the pendulum experiment. Can we give a virtual hand to Sir Nel and Ma'am Cheska who prepared the video and the experiment, who performed the experiment? So thank you, Ma'am Cheska and Sir Nel. And I'm sure some of you have questions to ask, but before we proceed to the Q&A, we will be first having a pop quiz. So we will be flashing a question, and the first one to answer the question correctly in the chat box will be the winner. So we know that there are participants watching us via YouTube, but this will only be open for those who are joining us here in Zoom. Okay ba yun? So let us, can we now flash the question? Sir, so the question is, when doing a timed run in FilSciHub, how long is the default setting for start delay or the default time before experimental duration? So when doing a timed run in FilSciHub, how long is the default setting for start delay or the default time before the experimental duration? So I'm seeing a lot of participants answering here in our Zoom chat box. So the correct answer is 3 seconds. Okay, so the first one to type the correct answer is Sir Rosales, Sir Ian Rosales. Can you turn on your camera, Sir Ian? Hello, Sir Ian. So
Hello po. Good morning.
Can you give us a quick introduction of yourself? Where are you a student or are you a faculty member? And where do you teach or study?
Good morning, everyone. I am currently teaching in Manresa School. As you can see, as my background, no. So I'm a physics teacher. I'm teaching grade 8 and grade 8 to 10 physics.
Right. Wow. Yeah. Congratulations again, Sir Ian. And someone will message you for your prize. Okay, so you have a prize for getting the correct answer.
Thank you.
Okay. All right, sir. So now let's call on Sir Nel and Ma'am Cheska to entertain questions from the audience.
Hello, good morning, everyone.
Good morning, Ma'am Cheska.
Good morning.
All right. So anyone, do you have questions to ask to Ma'am Cheska and Sir Nel? Okay. Sir Nel or Ma'am Cheska, I would like to ask, are sensors or mobile applications like the ones mentioned by Dr. Rhea in the introduction, the FIFOX and Physics Toolbox, are they designed to work for a specific experiment as shown in the video, or can we also perform or explore other experimental setups?
Okay, let me answer that question. So I've been using this VFAX experiment, so you can use so many sensors in your smartphone, and of course it will depend on the type of smartphone that you have. But if you have a pretty nice smartphone with several sensors, you can already do experiments, not only the ones presented here, like the one in the free fall or the one in yeah, the one that we're doing. But you can attach this to different devices. For example, to a spring. So if you connect it to the spring, you can look into simple harmonic motion. And you can make use also of the sound, no? So meron siyang parang microphone and then yung speaker. So you can do, for example, measurement of sound, yung sound speed. You can do that like a sonar. Alam niyo yung sonar, yung pag nag-reflect yung sound, you can measure yung distance of the object. So there are other things like meron siyang accelerometer, meron siyang gyroscope. So pwede kang magawa, for example, na ilagay mo siya sa spinning object or material and then you can measure forces, no, yung mga angular acceleration, angular velocity and so on. That can be done. So it depends on yung gusto mong gawin. Kasi
Yes.
the sensors are general, so you can make use of them, no? Marami siya. May GPS, meron siyang sa sound syempre, sa magnetism pwede rin kasi may magnetometer. So you can do experiments with magnets. And not only in class activities, you can also do this in research. Kasi same instruments are being used in doing research work. As long as you are creative, you are innovative, you can do a lot with this simple smartphone. Yeah, maybe you can have it, let's say, try it, put in a balloon and let it fly or whatever. But of course, that will be risky. We do that. We can also put it in a boat and let it, say, pass travel waves. And for example, you can do that. But of course, yeah, you have to be creative in the experiments.
Yes, thank you, Sir Nel. We have questions here in the Zoom chat box. So, from Alfie Badilla, how accurate is the result using this app?
Sino masasagot si Ma'am? I can answer also kasi
You can answer it yourself. Sorry, Nel.
yes. Okay. So, it depends on the setup, no? Kasi when you're using PPAX, hindi lang naman siya yung yung gagamitin mong instrument. So, you have other components that you have to put in. So, the accuracy will be based on yung proper setup mo, no? That's why mayroon tayong mga susundin na mga guidelines to be able to maximize yung effect. So, yung error nito siguro 5%, depende, ganyan. So, pwedeng mag 10% kung
Yes.
okay yung yung gagawin mo.
Apo. But can we calibrate it first before we can use it?
Merong part na pwede i-calibrate, like for example, if you're trying to use yung sa sound, no, yung meron tayong tinatawag dito na yung acoustic stopwatch, for example. In the acoustic stopwatch, you can use clapping to start out stopwatch and end it by clapping. And you can calibrate it because it can pick up yung sa environment noise and that will trigger yung experiment mo. There's a good example of that in free fall, no? Yung gagawin dito is you place a balloon, tie up some weights, and then you burst the balloon so it will produce sound. And then when the body reaches the floor, meron siyang plate, so magpo-produce siya ng sound. And then you can measure acceleration due to gravity already with that very simple activity. Yon, pwede mong gawin siya and then you can calibrate.
Okay, sir. Thank you po. And we have another question here regarding the app itself. So, can FreeFox run online, either online or offline, is it compatible in any Android OS version?
Yes, you can download the FilSciHub application and then you can perform experiments offline. And then I think available siya for Android 4.0 and OS version. So yung ibang mga cellphone kasi for example yung ibang mga cellphone kulang siya ng sensor, pero I think lahat ng mga Android cellphone may accelerometer. So depende din sa, katulad ng sinabi ni Sir Nel kanina, depende din sa cellphone na gagamitin. Yung ibang mga cellphone equipped sila ng maraming sensor, and then yung ibang mga cellphone may ibang sensor na hindi kompleto. Okay, so depende din sa mobile phone, but I think lahat naman ng mga cellphone may accelerometer, so you can do so many activities with an accelerometer sensor.
And also free yung app,
Yes.
no, ma'am?
Yes, free po yung FreeFox. And then kahit yung application na gagamitin mamaya sa experiments with Sir Arvin, free po yung mga applications na ipapresent namin this webinar.
Alright po. And I think we have a last question here about the calibration. So may clarification lang po dito. Can we also use it to calculate error percentage rin as part of the experiment?
Maybe Sir Nel, yung calibration na ni-refer yung kanina, sir.
Yeah, it's really kung gusto mo yung sa calibration, okay, magagamit mo siya to make mas exact measurement. Pero yung in terms of yung analysis ng data mo, siguro you would need another software to look into to your data. For example, pwede mong i-gather yung data and then you can plot the data. But yung nakukuha mo sa FIFAX kasi yung mga live na mga graphs, for example. Pero if you want to really analyze, pwede mong gamitin ibang software like yung basically yung mga spreadsheets and then ipa-plot mo yung graphs mo. So, yung mga teachers can really parang gagawa sila ng activity na designed for the student, no? Hindi lang siya purely PFAX. Pwede mong samahan siya ng activities para siya yung buo yung yung experiment mo. Okay? So siguro in the future will be featuring some of those, 'di ba, ma'am? Na kung meron pa tayong mga susunod, we'll feature some of those na paano yung complete package noong experiment. Kasama na yung mga analysis po.
Yes. Okay.
Thank you very much po dun sa mga questions. Very useful po yung mga questions ninyo. And may mga questions pa yata, Ma'am Ella.
There's a question here. Is there a particular Android version with which the FIFAX can be used, and how do we confirm the sensors available in our phone? I think yung sensors available in our phone, tama ba? Nasa search naman yan?
Yes, correct.
Internet.
Kung, Ma'am Ella, yung and then si Sir Mark, yung sinasabi ko kanina na sometimes hindi kumpleto yung sensor. So makikita nyo lang dun sa application nyo, pag kinlik nyo, nakalagay sensor not available. So for example, ibang phone na walang gyroscope, and then nakalagay sensor not available.
Alright. So, ma'am, there's a question here. Are there available video tutorials for the other experiments? So, itong Pendulum experiment is just one of the experiments that we can perform using FIFAX.
Yes, thank you, Ma'am Rolina and Janus. So, marami pong mga video tutorials from YouTube and also dun sa FIFAX website. Nandoon yung may mga sample teacher's guide or activity sheets and video that you can use as inspiration po para i-design yung inyong mga laboratory experiments. So katulad po ng sinabi ni Sir Nel kanina, maganda po na mag-explore din tayo on our own on how we design our experiment. And then we can use this application as basically sensor para to guide us and to help us gather data. Thank you po. Maraming salamat. Ang gaganda ng mga questions ni na Ma'am and Sir.
Yes. And somebody from the Zoom chat box confirmed na it will appear if available po yung sensor.
Yes. Thank you, Ma'am Jeannie.
Alright po. We have a question. One of our participants from YouTube sent this question. So can we facilitate this experiment, especially in remote areas where the students don't have access to smartphones?
Very good question. Thank you for that question. Actually, for this particular experiment here, yung role talaga ng application ng FIFAX is to measure the frequency. Okay, so kung walang mobile phone yung student, then pwede naman na medyo mano-mano stopwatch. And then maybe you can count the oscillation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you measure the time, and then you divide it by 10 to calculate for the period. So hindi lang po tayo makakakuha ng gyroscope data, yung oscillation niya, kasi wala tayong application. But for example, kung walang mobile phone yung bata or hindi natin ma-download yung FIFAX, then we can also do this experiment remotely. So yung mga materials very accessible lang po naman. So we can also perform this kung medyo limited yung resources po ng students. So thank you very much. Very, very good question po.
All right. Thank you, Ma'am Cheska. All right. So I think we have answered all the questions, Ma'am Cheska and Sir Nel. Okay, so thank you, Sir Nel and Ma'am Cheska, for preparing this experiment and for entertaining the questions. And I hope that the participants learned a lot from the open forum, right? So that has been a very engaging question and answer portion, right? So